Okay, we're back. So let's look at number 3. It says a motorboat goes 36 kilometers downstream in the same amount of time that it takes to go 24 kilometers upstream. If the current is flowing at a rate of 3 kilometers per hour, what is the rate of the boat in still water? Okay, so this time we have our current. So we have rate times time equals distance, and we're going to be going down stream and then upstream. I'm just going to do down and up. Okay, so our rate. So if we're going downstream, remember that that 3 kilometers per hour that the current's flowing is going to be added to that. So it's going to be R plus 3 this time. And then if it's going upstream, we're going against the current. So it's going to be R minus 3. Says if the current, okay, what is the rate of the boat in still water? Do we know the time? We sure don't. That's staying T. Do we know the distance? Yes, we go 36 kilometers downstream, but only 24 kilometers back upstream. This top equation becomes T times the sum of R plus 3, or R and 3, equals 36. The equation below it becomes T times the difference of R and 3 equals 24. Okay, so in this one, if we were to get rid of the T in each of those equations, we'd have some type of fraction. Like in the top one, we'd end up with R plus 3 over 30 equals 36 over T, or in the second one, we'd end up with R minus 3 equals 24 over T. So this time, we're going to go ahead and distribute. We're going to distribute the T into the sum. So we get RT, or TR, however you want to write it, plus 3T equals 36. And then we're going to do it again, and we're going to get TR minus 3T equals 24. This time, instead of getting rid of getting rid of the 3T and the negative 3T, I'm going to get rid of the TR. How do I do that? Well, we have the same sign here, so I'm going to subtract. That means I have to subtract all the way through. TR minus TR is gone. 3T minus negative 3T becomes 3T plus 3T, or 6T, and 36 minus 24 is 12. So we get to divide by 6 and get T equals 2. Okay, so T equals 2, remember this is time. So we're going to take and plug that in to one of the equations here. And it looks like we're going to be plugging it in there. Or you could have plugged it in to the very first one if you wanted to, where it was T times the sum of R plus 3 equals 36. So we're going to get 2R plus 3 times 2 equals 36, or 2R plus 6 equals 36. We're going to subtract 6. Again, if you can do that mentally, go ahead. You get 2R equals 30, and then divide by 2. You're going to get R equals 15. So what is the rate of the boat in still water? The rate in still water is 15 kilometers per hour. Okay, that takes care of number 3. We have one left. Anne can paddle her canoe 15 miles downstream in 2 hours. The return trip upstream takes 3 times as long. What is the rate of the current? So rate times time equals distance. She's going down, she's coming back up. Okay, so this time, we know her time is 2 hours. We know the distance is 15. So it's our rate, R plus W going down. The return trip is R minus W for the rate, but it takes 3 times as long. Well, 3 times as long means 2 times 3 or 6. And so how far? She's still going 15 miles back. Okay, so in the first one, we end up with 2 times the sum of R and W equals 15. And in the second equation, we end up with 6 times the difference of R and W equals 15. The first one we'll divide through by 2. And when we do, we get R plus W equals 7.5. I'm writing that as a decimal. Okay, and the second one we'll divide by 6. I don't know why I put 2. So we get 6 times the difference of R and W divided by 6 equals 15 divided by 6. Okay, so we get R minus W equals 2.5. Okay, what do we want to get rid of? It's up to you. I'm going to get rid of W, so I'm going to add. I'm going to get R plus R is 2R. W plus negative W is gone. Equals 10. Divide by 2. R equals 5. And let's see what it's asking us now. What is the rate of the current? So this is the rate of the current in still water. Let's see. Well, that's the rate of still water, not the current in still water. Now we're going to take and put that in, and we're going to get 5 plus W equals 7.5. We're going to subtract 5, and we're going to get W equals 2 5/10 miles per hour. The return trip upstream takes 3 times so long. What is the rate of the current? Okay, so the water current is our W, so it becomes 2.5 miles per hour is the current of the water. Okay, so this finishes not only this lesson, but this whole unit, which means that we're going to be getting ready to prepare for a test and not too many more days. So just be aware and be following posts and assignments that I put up. Remember that every morning I have video hours from 8 a.m. to 10 a.m. So if you need any help with anything, please reach out to me during that time. It's going to be easier to possibly explain things that way. But I'll always do my best answering any questions y'all have by messaging. And thank you for all the effort y'all are putting in so far. It's I so appreciate it, and I'm really taking the time to look over everyone's work and try to give feedback as needed so y'all can stay on top of your learning. Y'all have a good rest of your day.